For decades, Mars remained humanity's primary target in the quest to colonize space. It became a symbol of our unwavering belief that one day we could transform the red planet into a second Earth. But recent discoveries have painted a far more sobering picture. Scientific reports from NASA and other leading institutions have confirmed that Mars's atmosphere is far too thin, only about 0.6% as dense as Earth's. It provides virtually no real protection from cosmic radiation or meteorites falling from space. Any drop of water on the Martian surface instantly evaporates or freezes. The dream of terraforming Mars, turning it into a habitable world, is not just distant, it may be fundamentally impossible for thousands of years. Meanwhile, on the far edge of the solar system, an unexpected contender is attracting growing attention. Titan, Saturn's largest moon. Once thought to be nothing more than a frozen wasteland, Titan is now capturing the imagination of scientists around the world. Titan possesses a thick atmosphere, about 50% denser than Earth's, providing strong protection against radiation and cosmic debris. The surface pressure is nearly ideal, and its enormous reserves of hydrocarbons, lakes and seas of methane and ethane, offer almost limitless potential for energy and raw materials. Most fascinating of all, beneath its icy crust, estimated to be 50 to 100 kilometers thick, lies a hidden ocean, an environment NASA considers one of the most promising places for life beyond Earth. So what makes Titan such a compelling candidate for future space missions? Why are scientists now calling it one of the most promising destinations for colonization, perhaps even more attractive than Mars? It is possible that Titan may one day overshadow humanity's long-standing dream of the red planet. Let's take a closer look at the scientific evidence behind this unexpected shift in the race to settle space. What you are about to discover may completely change the way you imagine humanity's future among the stars. Long before Titan captured the attention of scientists, Mars was seen as the red desert where humanity could one day continue its existence beyond Earth. But as science advanced and our understanding of the planet deepened, a harsh reality began to emerge. Mars is an unforgiving and extremely hostile world. It all begins with the atmosphere, the key factor for the emergence and survival of life. On Mars, the atmosphere is incredibly thin and composed of roughly 95% carbon dioxide. The air is impossible to breathe, and the atmospheric pressure is so low that no human could survive without a fully sealed protective suit. In addition, this fragile atmosphere offers almost no protection from cosmic or solar radiation, causing radiation levels on Mars to exceed the safe limit for humans by nearly 200 times. Even small meteorites that would burn up harmlessly in Earth's atmosphere can reach the Martian surface, creating a constant threat to any future colony. The atmospheric pressure on Mars is far too low for liquid water to exist openly on the surface. Any drop of water exposed to the environment would instantly evaporate or freeze depending on the conditions. That is why the ancient river valleys visible in Martian images are nothing more than fossilized remnants of the past, not evidence of present-day flowing water. Temperature is another major obstacle. Although Mars receives sunlight, its thin atmosphere cannot retain heat effectively. This leads to extreme temperature swings between day and night. The average surface temperature is around -63 degrees Celsius, but during the night it can fall to -120 degrees Celsius, cold enough to damage metals and disable electronics without heavy thermal protection. Even near the equator, daytime temperatures under direct sunlight may briefly rise to about +20 degrees Celsius, but as soon as the sun sets, they plunge far below freezing again. And finally, there is the dust. Fine, omnipresent, and dangerous. The Martian surface is covered with dust containing perchlorate, toxic compounds harmful to humans. During global dust storms, these microscopic particles can remain suspended in the atmosphere for weeks or even months, creating hazardous conditions for any mission. Faced with these challenges, some scientists propose the idea of terraforming, altering Mars' climate to make it more Earth-like. However, studies by NASA and ESA indicate that Mars simply does not contain enough carbon dioxide reserves to significantly thicken its atmosphere. Even if all available CO2 were released, the atmospheric pressure would rise to only about 7% of Earth's. That is still far too low to support human life without protective suits. Moreover, proposals involving the use of nuclear weapons to trigger this process carry unacceptable risks of long-term radioactive contamination, undermining the very goal of creating a safe environment. The truth is unavoidable. Nearly every aspect of Mars resists life. Humans could not survive there without importing almost every essential resource from Earth: water, oxygen, food, and construction materials. All of it would have to be transported across space at enormous cost and risk. Although Mars is closer and more familiar than Titan, it may ultimately serve more as a scientific outpost than as the final destination for a thriving human civilization. If Mars can be seen as a harsh laboratory for survival, then Titan opens the door to an entirely different kind of world, distant, frozen, yet filled with the promise of life in forms we have never imagined. Located more than 1.44 billion kilometers from Earth, Titan, Saturn's largest moon, is not the kind of destination people usually dream about. But to scientists, Titan is far more than just a moon. It is an entire world where life may emerge without sunlight, possibly in forms completely unknown to us. Titan is the only moon in the solar system with a truly dense atmosphere. According to data from the Cassini mission, the atmospheric pressure on its surface is about 1.5 times higher than Earth's, similar to conditions 15 meters beneath Earth's oceans. Its atmosphere is composed of 98.4% nitrogen, much like Earth's, along with 1.4% methane and traces of hydrogen, ethane, acetylene, and other hydrocarbons. This means that humans would not need fully pressurized spacesuits as they would on Mars or the Moon, only heavily insulated protective clothing. In a universe where most worlds are hostile to life, Titan presents a strange balance between physics and the potential for biology. Its atmosphere creates a complex chemical weather system. Methane and ethane exist there as liquids, forming lakes, rivers, and even rain. This was first confirmed during the Cassini-Huygens mission in 2004 to 2005. The amount of liquid hydrocarbons on Titan is estimated to exceed all of Earth's oil and natural gas reserves combined by hundreds of times. Its lakes, rivers, and rainfall are made of methane, ethane, and propylene. Simple hydrocarbons, extremely useful for producing fuel, plastics, and construction materials. On Earth, such substances are the result of complex biological and geological processes. On Titan, they are simply part of the natural cycle. Titan is not a dead world. It is a functioning chemical ecosystem, and that opens the door to genuine energy and material self-sufficiency, something Mars cannot currently offer. Beneath Titan's icy crust lies a vast ocean of liquid water, potentially around 200 kilometers deep. Data from the Cassini mission suggests this ocean may extend across the Moon's entire interior. Its temperature is estimated to range between -20 degrees Celsius and 0 degrees Celsius, maintained by immense internal pressure and antifreeze compounds such as ammonia. The pressure within this ocean may resemble conditions found in the deepest regions of Earth's oceans, environments where life exists without sunlight, powered instead by hydrothermal energy. If life could emerge at the bottom of Earth's oceans, why could it not arise on Titan? Titan's thick atmosphere, combined with Saturn's powerful magnetic field, creates one of the few natural radiation shields in the solar system. While astronauts on Mars or the Moon would likely need to live underground to survive radiation exposure, Titan offers a far safer environment. Its landscapes appear surreal. Icy mountains, frozen plains, and dark methane seas create the image of a strange, slowed-down version of Earth. But most importantly, Titan allows us to imagine a future without artificial domes and endless oxygen pipelines. With atmospheric pressure capable of supporting human presence, abundant energy resources, vast reserves of ice, and the potential for life, Titan is not merely a place where humanity could survive. It is a place where humanity could build a new civilization, a new beginning on an alien yet hopeful world. While Mars demands constant struggle and adaptation, Titan invites exploration, understanding, and construction by taking advantage of its unique natural conditions. Perhaps humanity's future does not lie in reshaping planets, but in choosing the right world to begin again. In the end, The race to colonize space is really a comparison between two worlds, their survivability, resources, and long-term potential for sustaining human civilization. On Mars, the atmosphere is so thin that humans would need sealed pressure suits at all times. Even a tiny crack could become fatal within seconds. That same thin atmosphere offers almost no protection from radiation or meteorites. Titan, by contrast, possesses a thick atmosphere and the added protection of Saturn's magnetic field, providing a natural shield against cosmic radiation. Beneath Titan's icy shell likely lies an ocean containing more water than all of Earth's oceans combined. By melting the ice, future settlers could obtain both water and oxygen through electrolysis, creating the basic conditions necessary for long-term habitation. Titan's atmosphere also contains up to 95% nitrogen, similar to Earth's atmosphere, making it highly suitable for growing plants inside enclosed greenhouses or hydroponic systems. On Mars, meanwhile, nearly all settlements would need to be built underground or inside sealed habitats. Every square meter of living space on Mars would be constrained by the harsh realities of survival. The absence of natural comfort, prolonged confinement, and isolation from Earth would greatly increase the risk of stress and depression, something already confirmed by Earth-based experiments, including Mars simulation missions such as the Hawaii Space Exploration Analog and Simulation Project. Titan, despite its extreme cold, would allow the construction of semi-open surface structures that would not require high internal pressure or massive protective domes. Its landscapes appear strangely familiar: lakes, rivers, plains, and icy mountains. Mars once had rivers, oceans, and a warmer climate as well, a fact confirmed by geological studies. But today, its surface is effectively dead. If microorganisms still exist there, they are likely buried deep underground, shielded from radiation and extreme dryness. So far, there is no convincing evidence of present-day life on Mars. Titan, on the other hand, may hide an ocean beneath its frozen crust, one that could potentially harbor life forms similar to Earth's archaea. Microorganisms capable of surviving without sunlight, relying entirely on chemical reactions for energy. NASA has officially identified Titan as one of the most promising places in the solar system for discovering primitive life. The upcoming Dragonfly mission, scheduled for launch in 2028, will send a flying drone to Titan to explore its surface, especially regions showing signs of unusual chemical activity that may point to biological processes. Thanks to the rapid advancement of space technology in the 21st century, Titan, Saturn's largest moon, has transformed from a blurry, icy sphere photographed by Voyager 1 in 1980 into a serious candidate for humanity's future beyond Earth. That vision became even more tangible after NASA officially approved and funded the Dragonfly mission, the first physical expedition to Titan's surface. The launch is planned for 2028, with arrival expected around 2034. The spacecraft will resemble a massive 8-rotor drone. Unlike Mars rovers, it will not travel across the ground on wheels. Instead, it will fly from location to location. Because of Titan's unique conditions, an atmosphere 1.45 times denser than Earth's and gravity only 1/7 as strong, flight there requires relatively little energy. Dragonfly will be capable of traveling distances of up to 8 kilometers in a single hop, exploring a wide range of landscapes: sandy plains, hydrocarbon-rich dunes, and especially Selk Crater, a region where liquid water may once have existed, creating ideal conditions for prebiotic chemistry. The mission's goals extend far beyond simple exploration. Dragonfly is equipped with instruments designed to analyze surface chemistry, measure magnetic fields, determine ice depth, detect cosmic rays, and most importantly, search for prebiotic molecules, amino acids, nucleotides, or signs of biologically produced methane. Some of these compounds were indirectly suggested by the Cassini-Huygens mission, but never directly confirmed. A successful Dragonfly mission could pave the way for the next stage: experimental settlement concepts already being studied by NASA, ESA, MIT, and the SETI Institute. In these models, habitation modules on Titan would be constructed using 3D printing technology with carbon-based polymers derived from its atmosphere and surface. Dome or cube-shaped structures, insulated with thick layers of aerogel, would be able to maintain stable internal temperatures ranging from plus 18 degrees Celsius to plus 22 degrees Celsius, even when outside temperatures drop to minus 179 degrees Celsius. The building materials would be produced from methane and ethane, both readily available on Titan. These can be liquefied and polymerized to form the foundation of homes, sealed compartments, and storage units. The energy system would not depend on sunlight, as solar intensity on Titan is only about 1% of that on Earth. Instead, methane-oxygen fuel cells would be used. Methane could be extracted from the atmosphere or lakes, while oxygen would be obtained through electrolysis of water ice. According to calculations by NASA's Jet Propulsion Laboratory, JPL, 1 ton of ice can yield approximately 888 kilograms of oxygen and 112 kilograms of hydrogen, enough to power a basic habitation module for several weeks. For food production, closed hydroponic or aeroponic systems would be used. The main crops would include kale, soybeans, sweet potatoes, and seaweed, chosen for their cold resistance and rapid growth. Titan's atmosphere, composed of 98.4% nitrogen, could be adapted to create an ideal environment for plant respiration and photosynthesis. Greenhouse designs would incorporate LED lighting systems with adjustable spectra, simulating sunlight and allowing plants to grow even under Titan's permanently dim twilight skies. However, despite this potential, the challenges remain enormous. Titan is located 1.4 billion kilometers from Earth, nearly 10 times farther than Mars. Even using advanced orbital transfer techniques, transport of humans and cargo would take 7 to 8 years. Radio signals require 80 to 90 minutes for a round trip, meaning that most operations would need to rely heavily on autonomous AI systems and local decision-making on site. A fully operational Titan outpost would need to function independently for at least 10 years. This is NASA's standard for future interplanetary settlements. Despite the scale of these challenges, Titan remains the only place in the solar system, apart from Earth, widely considered realistically suitable for long-term habitation. Moreover, Titan hides an unsolved mystery, a subsurface ocean that may contain traces of primitive life. This single possibility transforms Titan from a mere outpost into something far greater, a new scientific and civilizational frontier that humanity has yet to cross. Mars may be a destination for explorers, but Titan could become a home for settlers, not because it is easier to reach, far from it. Titan presents immense challenges in engineering, logistics, and time, yet it offers precisely the conditions for sustainable existence that Mars lacks. An atmosphere capable of shielding humans from radiation, a chemically rich environment capable of providing fuel and construction materials, vast reserves of water ice, and, most importantly, the long-term environmental stability, the foundation of any enduring civilization. If humanity truly intends to build a permanent settlement beyond Earth, not for years but for generations, Titan stands as the strongest candidate. Why Titan is worth colonizing? There are no global dust storms here that could bury entire cities, no extreme daily temperature swings, no need to live permanently underground. On Titan, we can imagine surface cities, habitation structures designed for cold rather than pressure, powered by resources extracted within a closed-loop system. A place not only for survival, but for a full and dignified human life. This is no longer science fiction. The closer world, Mars, is filled with risks and compromises. The more distant, colder, and harsher world, Titan, holds the potential to sustain life across generations. If you believe that humanity's future is not limited to this small blue planet, then Titan may become the universe's first invitation, a world waiting to be filled with light, life, and the first human footprints along its icy shores.